Okay, hello everybody. Today we'll be learning about the Einstein's special relativity. So what we have to know first about Einstein's special relativity was that like before Einstein's special relativity you had Galileo, and then Galileo he introduced that all of mechanics is the same in all inertial frames of reference. Now, an inertial frame of reference is basically a reference in which the acceleration is zero, or and in which all of Newton's laws of mechanics apply. So, one of the biggest controversy at this time was that will the speed of light change? Like Galileo or Newton introduced that the speed of light will change based on your reference frame. Like like if you're moving, like Galileo also introduced that your speed that the speed of light relative to you relative to you will change based on your relative velocity, based on your velocity relative to the light. So this is what Galileo introduced, yeah, relative to the light. So these are the two concepts in which Galileo introduced. Okay, so from Galileo's principles that we learned before, uh, from Galileo's principles, like here and here, we see that based on your speed relative to light, like here, your speed relative to light, your you would see a greater speed or a less speed, as can be shown, or a resultant that looks like this. So this is what can be seen from Galileo's principles that describe the speed of light. So what was wrong about this? So what was wrong about this, before it could be made a general statement, it has to be tested. So this is where we go into the Michel and Morley experiment. Now Michel and Morley, they figured this experiment out. So the way in which the Michel and Morley experiment was conducted was that they knew that the rotation, like the Earth is revolving around the sun, and that at different times of the year, like the speed, if the speed of light does change based on different reference frames, that the speed of light will change at different times of the year, as can be seen here. Like the speed of light moving into the Earth head on, it would be c plus v when the Earth is head on with the sun. And then based on so Michel and Morley experiment, they conducted the experiment like every single year, like different times of the year they would measure the speed of light, and they figured that speed of light is the same in every single reference frame. And this is like a big contradiction to the Galilean principles. And this is where Einstein revolutionizes the whole concept of relativity and physics itself. So Einstein's first principle says that if you have two objects, like two spaceships, and they're moving with like different velocities, or that it is impossible to tell which object is stationary and which object is moving. Because if you have a person inside this spaceship and moving with constant velocity, then he thinks he's at rest, and the whole universe is moving around him. And if you have this spaceship, the same goes for this spaceship too. So, and this is also a general statement that also applies for planets as well, because let's say you have this globe, this planet or whatever. say you have this planet. Yeah, let's say you have this planet. If you have this planet and you have this person, say here, and he's on this planet, and you have this person and he's on inside the spaceship, then this guy, this guy looks, if he's moving with constant velocity, then he thinks he's at rest, and this planet is moving, and this planet is moving. But then this guy, he thinks he's at rest inside this planet, and the spaceship is moving. This is basically the gist of Einstein's first principle. Now, now Einstein's second principle of relativity is that the speed of light is constant in every single reference frame, as we proved from the Michel-Morley experiment. Proved in the Michel-Morley experiment that the light is the same at every single reference frame, and this is basically from Maxwell's equation. Maxwell was the first one to postulate this. Maxwell was the first one to postulate this because from his equations he saw that the speed of light must be constant because the factors. Maxwell, yeah, because since the factors, since the factors of electricity, electricity, uh, factors of electricity and magnetism do not change, based on your reference frame, reference frame, then the speed of light, then the speed of light must also be the same in every reference frame. And as we showed before, Michel-Morley experiment also proved this to be correct, and Maxwell was the first one from his equations to postulate this factor. So this is very significant for Einstein's special relativity, because this is the second principle of Einstein's special relativity, that based on any reference frame you are, how fast you are moving with respect to the speed of light, the speed of light is still the same, no matter what reference frame you're in. And this is basically the gist of in Einstein's second principle that we will use to derive the time dilation.